So, geotrig, lesson 14, the beginning part here is sohcahtoa, or sine, cosine, tangent. So sine, cosine, and tangent are very important. Okay? Yes, that is sine, cosine, and tangent with the e's on there. A lot of times we don't see it with all of those. We sometimes, I'm going to jump here a little bit, we see it with just, oh, sorry, wrong one, sine. Sine would just be S-I-N, like sin. So sometimes kids say sin when it really is sine, or at least in math. Cosine is C-O-S for cosine, and tangent we just use tan. Those three buttons are on your calculator. So these things, the sine, cosine, and tangent is very helpful. It's used with certain special triangles, and we'll get to that in a second. Now, I learned this using a certain phrase. It might not be politically correct, but it was called, the guy was Chief sohcahtoa. Because it sounds like maybe like a Native American name or something. I know it's not correct word to say, but sohcahtoa, or if you stub your toe on a rock, you want to soak your toa. So sohcahtoa, guys, it's just I don't want to say it's an acronym. It's an acronym, I guess we could say, that stands for sine, cosine, and tangent, and what they actually mean. And so there's another way that we can remember it. Now the book uses some acorn thing, and I don't like it because it doesn't make a complete connection. I like sohcahtoa because when you say sohcahtoa, you can actually see the S-O-H, C-A-H, and T-O-A that come out of it. Or you can kind of think of it as you're saying it. But there's another one that I got from a couple students last year or the year before that I guess Mr. Helichek uses. And he says, some old hippie caught another, did I spell hippie wrong? No. Okay. Hippie tripping, is it tripping with two P's? Tripping on acid. So, some old hippie caught another hippie tripping on acid. So, the whole thing, guys, is just about trying to remember those words or letters in that specific order. Because if you look at the first letter of each one of those, I'm going to switch to a better color here for us. You get S-O-H. So, C-A-H, Ka, T-O-A. Toa. That stands for, or helps us identify what does sine, cosine, and tangent use, or what's the ratios, because sine, cosine, and tangent are ratios. So let's talk about what those ratios are. The ratios for sine are O over H, which means opposite over hypotenuse. Yep, sine. So sine is the opposite over hypotenuse. I'll change colors for you guys because I see that's not the best color for up here. Cosine uses what letters? C-A-H. So C is the cosine. A stands for adjacent. And H is still the, whoops, hypotenuse. And O, what's that? No, probably not. So, T is for tangent. O, A means opposite over adjacent. That helps us, guys, remember the ratios. Now, what this means is that with that next starred thing on the bottom there, these only work on right triangles. These only work on right triangles. So, you know you have to see a right triangle. And then another thing is that these ratios can also work, these ratios can either find sides or they can find unknown angles, and we actually call unknown angles with that symbol, which is what? Is that how you spell theta? I think that's how you spell theta. It's a theta. It's a circle with a line through it. That would be an unknown angle. So, I'm going to, on the next slide here, we're going to demonstrate how it's going to change. But here we go, on this one at least, if I say here's theta, that's the angle that I'm talking about. Whether I'm given an angle or I have to find an angle, I can use those three ratios to find all the sides or the angles. Okay? Now, if I'm at that theta, opposite, guys, is here. The longest side, which is opposite 90, is always the hypotenuse. And the one that's right next to it is the adjacent. On the next slide, I'm going to show you that that's not always going to stay that way. Okay? So next, are we all ready? So the first thing there is, in order to isolate theta, we must use the inverse trig functions. And they're functions just like sine, cosine, tangent are functions. The first one would be sine. It's freezing. Okay, there we go. With a little -1 above it. Cosine with a little -1 above it. And tangent with a little -1. And again, these can be found above your sine, cosine, tangent buttons on your calculator. The ones without the little -1s above it. Now, when working with the sine, cosine, and tangent, you must first mark off the angle that you are working with, and then you may label the sides opposite, adjacent, hypotenuse. For your first several problems that you start to use sine, cosine, and tangent for, I think it'd be very helpful if you established the angle by saying this is my angle, and actually writing opposite, adjacent, and hypotenuse on the appropriate sides. It's going to help you long term to figure that out. After a while, you don't have to. You'll start to get it, and it'll be nice and easy for you. Now, big thing here, students get mixed up often, is the fact that opposite and adjacent sides are directly related to the angle you choose. Now, we know that we are dealing with a right triangle. So I'm going to draw two different right triangles. One of them is just like the problem we had before, where theta is in the bottom right corner. Or we could say theta's in the top left corner. When I do this, something does stay the same. What stays the same? What never changes in a triangle? The hypotenuse. The hypotenuse will be the same. But, like I say there, the opposite adjacent will change. So do not go into a problem thinking that this always has to be true, because it depends on the angle you're working with. And sometimes you will use both angles in a problem to solve it. So you have to make sure that you switch gears and figure that out. Opposite is the side that the angle opens to. So opposite is the side that theta is opening to. So on the left one, it's on the left. But on the triangle on the right, it opens to the bottom. So by having a different perspective, it changes the orientation or the look of where opposite and adjacent is. It's kind of like when you're facing somebody, you say, go right, and they go to your left. Interesting, right? They got a different perspective than you. So each angle has a different perspective. Just like if I'm at that bottom, the left triangle, and I want to be adjacent to myself, to be next to, then that side is on the bottom. But if I was in the top left, the adjacent is on the left side of the triangle, or the height in that particular one. So it does change. Be very mindful of where you are at in the triangle. Now, on top of this whole idea of, guys, of having triangles and using sine, cosine, and tangent, the problems are going to be your real life problems that come out of it is you're walking outside and you're walking and you're like, see this bird's nest in a tree. And you're like, wow, that's a really nice looking bird's nest. I wonder how tall in the tree it is, or how far off the ground it is. And so what you're doing, guys, is that you're standing on the ground and you're looking up. That would be called an angle of elevation. So your line of sight is looking at the bird's nest that is up in the tree. So, it's fall. That's why you can see the bird's nest. Now, other way around, now you're in an aeroplane and you sight this really cool looking pool on the ground. That's a really cool looking pool. Really cool looking pool on the ground. And you're thinking, how far down is that pool below my plane? You looking down, so it's down. It's called the angle of depression. Okay, so you are going down depression, so therefore you'd have your theta there. So watch. Theta is your angle. Theta would be in both of those from the ground to your line of sight. Okay, so you're looking down or looking up. That's going to help us with some problems because it's going to... Now, there's some things you got to assume. Now, I know this is not perfect.
Never assume
What's going to happen is it's not so bad when you're in an airplane and your angle of depression to the ground. That can make sense. But where do you see from? What are you looking through? You're looking, or even from the ground. If you're walking on the ground, where are your eyes? On your head. Is it at ground level? No. But in our problems, you got to realize that when you're standing there, your eyes are here. That means you are about, for some of us, it's only 4 feet off the ground, but but for the rest of us, it's about 5.5, 6 feet. So you have to sometimes take in consideration that there is a height difference between your eyes and the ground level. Now, if the problem doesn't state anything that the person is, 5 feet tall, then you just assume that they must either be laying on the ground looking up at this thing. Just take it as the eye level is how the height starts, okay? So in these ones, we have to solve each triangle. The important part to know is to solve a triangle suggests that you find all unknowns, whether they're stated or not. And that includes angles and sides. Okay? So there's some nice things about our sides. If you're given 2 of the 3 sides, well, then you can just use what theorem? Pythagorean's theorem. Okay? And that will give you an answer. Now, there's a lot of times these answers are not going to turn out nice. So when these answers don't turn out nice, you leave it in square root form. Things like that.
Is that 10 or 20?
That is a 6, a 10, and an 8.
I thought that B was an 8. Oh,
that's a B?
that's what I thought.
So what we're going to do, ladies and gentlemen, we are going to find, whoops, sorry, X and Y. The only thing we got left are those 2 angles. So I'm just going to call them X and Y so I don't get them mixed up. So we have options. Okay, we all like to have options. That's why we wear the dress code, so we have lots of options. And so here we go, ladies and gentlemen. Let's start off with X. If I'm working with X, what's opposite?
Y.
So I'm going to write opposite. What's 8?
Opposite of 10.
Is the 8, and the hypotenuse is always going to be the 10. Now, I'm just working with X. I want to solve for X. Now, this is our options. I have all 3 sides given to me, yes? Which means, if I try to use, I'm going to go back. If I try to use any of these ratios, I know an opposite and a hypotenuse. I know adjacent and hypotenuse. I know opposite and adjacent. All 3 will work. I have my options out left for me. Which one do we want to use? Sine, cosine, or tangent? Okay, let's use tangent. Tangent of X is going to equal what? Opposite over adjacent. You can use any of the 3. So, what's opposite? 6 over 8. And now we just have to solve for X. Well, we could simplify that, right? Tangent of X is equal to 3/4 or 0.75. Okay, but now, here's the thing. Take your calculators out, people. Now, here's the thing. I'm taking the tangent of X. Sine, cosine, and tangent, you can only use angles in it. Okay? You can't use the ratio. We're not taking the tangent of 3/4. That's going to be wrong. What we need to do is we need to get X by itself. And so, to get X by itself, I need to take the inverse function of both sides. What's the inverse function of tangent? It's because it becomes the inverse tangent. Listen carefully. I am going to, this is the proper way to do this, the inverse tangent of both sides. Okay? And an inverse of a function, and if you remember back, we did the composition of functions, they would undo each other, right? And all you'd be left with is X equals. The X is the input becomes the answer on that left side. And what does it equal? It equals the inverse tangent of 3/4. And now you type that into your calculator. What is the inverse tangent of 3/4? Now, careful what calculator you're using. If you got a scientific calculator, in a graphing calculator, you can actually type in inverse tangent, which is second tan. You should show the tangent with a little -1. Put parentheses if it's not already there. 3 divided by 4. End your parentheses. Hit enter.
6.6.
No, that doesn't seem right.
36.8.
What'd you get?
36.8.
36.87. So 36.9.
Yeah.
Okay. Hold on. We're going to get there. We got to go through these troubles at first. Now, how are we doing this? First of all, make sure your calculator is in degrees. How do you make sure your calculator is in degrees? You got to go to mode. Everybody, if you got a graphing calculator, go to mode. If you're in a scientific calculator, you got to make sure your DRG button, the drag button it looks like, goes to degrees. Usually on a scientific calculator, you hit clear all, it defaults back to degrees on a lot of them. Some others you have to go and set it. You need to have it say degrees. So if you have to, go to the part where it says radians, degrees, move over 2 degrees, hit enter, and then you can clear it out. And you end up with 36.86 or 36.9.
Is that what it's
RAD stands for radians. We'll get to radians in a bit. We're just going to stick with degrees right now.
What's that there? What's cosh?
So hopefully we found all the problems there. Make sure you're in degrees. Ladies and gentlemen, now we need to find y. So we're going to ignore this other problem for now. Okay? Ignore this for now. We got to find y. Y we'll do in blue. Now if I go here, opposite then is not adjacent anymore. It becomes opposite.
Where'd the other one go?
I erased it. We're gonna skip it for now. We'll come back to it. So adjacent and opposite are switching because the opposite of angle y is down below. And adjacent's next to it. Hypotenuse, hey, it stays the same. Remember, it's where are you on the triangle, opposite, adjacent will adjust. Okay, we need to set up the same exact thing as we did for x. I don't want to use tangent. I have all the other options. Let's use sine this time. So the sine of y is equal to what? What's sine? Sohcahtoa. Opposite over hypotenuse. Have a great day, guys.